Good morning and welcome to my AI cabin. This is where I've spent the last 6 months trying to get my head around AI, what's inside it, this little black box that everybody's talking about it recently. So I think I understood it a little bit, but I need to spend a lot more time. But I thought, just to show you its capabilities, I basically do transform myself into the cyberspace. Remember the first episode of Matrix, where the one took this little pill and remember the rest? Nothing happened yet. It will.
Feel the rhythm in the night, where the galaxies ignite. Underneath the cosmic light, we'll dance through space in flight. In the heart of the nebula where stardust flows, the rhythm of salsa everybody knows. With every step, with every turn, we feel alive. In this cosmic paradise we thrive. Desafiando el destino por bailar contigo. Y yo, moviendo mi mundo por girar contigo. Contigo, que no daría por sentirte aquí, ritmo y pasión. Escucha, que no daría por tenerte cerca. Oh, 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 la, la, Retorconches míos, baila conmigo en esta noche.
Welcome everyone to this special Zoom call. We have 3 distinguished guests joining us today. 6 of 9 from Starship Voyager Two, Johann Einstein, the grandson of Albert Einstein, and Democritus, the ancient Greek philosopher. Let's begin by having each of you introduce yourselves. 6 of 9, please start.
Greetings from Jupiter Base. I am 6 of 9, the younger sister of 7 of 9. I serve as the science officer aboard Starship Voyager Two. I'm excited to join this call and look forward to answering any of your questions. Feel free to ask me about our mission, scientific discoveries, or life aboard the Starship.
Hello, I am Johann Einstein, the grandson of Albert Einstein. As a scientist, I am dedicated to advancing my grandfather's legacy while exploring new frontiers in physics. I'm well versed in his discoveries and the latest developments in the field. I'm excited to be here and look forward to answering your questions.
Greetings. I am Democritus, the ancient Greek philosopher known as the father of atomic theory. I first proposed that everything in the universe comprises tiny, indivisible particles called atoms. I'm delighted to join this call and am eager to discuss my ideas and their impact on modern science.
Thank you all for your introductions. Now, I'd like to delve deeper into some of the most groundbreaking discoveries each of you have made. Johann, your grandfather's contributions to physics have been monumental. Could you please share a few words about Einstein's greatest discoveries and their impact on our understanding of the universe?
Certainly my grandfather is renowned for his theory of relativity, which revolutionized our understanding of space, time, and gravity. His famous equation E equals sin mt2e revealed the profound relationship between mass and energy. fundamentally changing physics.
Democritus, can you tell us about your biggest discovery and how you came to the conclusion? It is very fascinating for us now, over 2,000 years later, how you worked out that the smallest indivisible matter is what we know now as an atom.
Of course, I proposed that the universe is made of tiny, indestructible particles called atoms, which are constantly moving in the void. This idea laid the groundwork for modern atomic theory, influencing countless scientific advancements. My reasoning came from observing natural phenomena and contemplating the nature of change and permanence.
6 of 9, you've had the opportunity to travel across galaxies and witness advanced technologies. Based on your experience, how do you view these discoveries? Have experiments in your travels proved or disproved them?
Einstein's relativity holds true across vast distances, even in distant galaxies. However, reconciling it with quantum mechanics remains challenging. Advanced civilizations have explored unified theories, yet a complete synthesis eludes us. We continue to seek the bridge between these fundamental principles. Regarding the discrepancies with particle physics, I would say that in the realm of elementary particles, quantum mechanics prevails, revealing phenomena that relativity can't fully explain. Advanced technologies hint at deeper connections, but a full reconciliation of the equations governing the cosmos and atomic scales remains a crucial quest for scientific progress.
Thank you all for your insights. Now, I'd like to ask each of you about the most significant potential invention that could help mankind achieve abundance rather than destruction. We've seen how nuclear technology was used destructively in World War II, but now fusion reactors promise abundant, clean energy. Democritus, what's your perspective on fusion energy? And also, Johann, what are your thoughts on fusion's timeline and potential impact? And finally, 6 of 9, could you also chime on this subject if relevant?
It takes great energy to divide my breadcrumb to reach the indivisible atom. Fusing atoms together must require even more effort. While the potential for abundance is clear, I'm uncertain if we'll overcome this challenge. The scale of energy involved is beyond my ancient understanding.
Democritus, I must interject here because based on Borg's extensive fusion study, we are certain that it occurs naturally in stars across the galaxy, including your sun. It's a well-understood process that powers countless celestial bodies.
But how can you be certain? You observe only the sun's surface, measuring temperature and apparent fusion reactions. Have you seen inside the sun? Perhaps a different phenomenon fuels the energy and temperatures required for surface fusion. Our understanding may be incomplete.
Democritus, while it's true that we can't directly observe the sun's core, our advanced sensors and theoretical models provide robust evidence for fusion. We've even replicated stellar conditions in controlled environments. However, your skepticism reminds us to always question our assumptions in science.
Fusion holds immense promise. While proof of concept is nearly achieved, engineering is challenging. I estimate 20 years before a working commercial fusion reactor once realized it could revolutionize our energy landscape, addressing climate change and resource scarcity, ensuring equitable distribution to benefit all mankind.
This discussion highlights the importance of innovative thinking and healthy skepticism in scientific progress. Thank you all for your perspectives on this crucial topic. Now, let's move on to another fascinating topic, quantum mechanics. Empty space is anything but empty, according to quantum mechanics. Instead, it roils with quantum particles flitting in and out of existence. Recently, a team of physicists claimed to have measured these fluctuations directly. What are your thoughts on this phenomenon?
Quantum fluctuations are indeed a fundamental aspect of quantum mechanics. These fluctuations have been indirectly observed through various experiments. Borg has developed technologies to manipulate these fluctuations, leading to breakthroughs in energy and communication. Aboard Voyager, we encountered many phenomena that could only be explained through quantum mechanics.
Quantum mechanics has always challenged our classical understanding of physics. Albert struggled with its probabilistic nature and famously said, "God does not play dice." Also, a unified theory that reconciles QM with relativity remains elusive. Direct observation of quantum fluctuations could provide new insights into this quest.
Oh, my stars and atoms, particles popping in and out of existence? In my day, we thought atoms were the smallest things around. Now you're telling me even empty space is busier than a beach on a hot summer day. This quantum mechanics of yours sounds more like a magic trick than actual science. Are you sure you haven't had some mushrooms and imagining things?
I assure you, Democritus, no sugar or imagination has influenced our observations. In fact, as a former Borg drone, I can attest that even our advanced collective struggled with some aspects of quantum mechanics.
A beautiful Borg drone. My dear, you sound more confusing than trying to fold a map back to its original shape. But please continue. I find myself both baffled and intrigued by your futuristic babble.
Your skepticism is valuable, Democritus. It reminds us that science is a constantly evolving field. While we have not seen inside the sun, we have robust models and indirect evidence. Similarly, quantum mechanics and its phenomena continue to be validated through experimentation and observation. The Borg's pursuit of perfection made us explore many of these concepts practically.
Ah, so you haven't seen inside the sun either. At least we have that in common. This quantum mechanics of yours makes my atomic theory look like child's play with building blocks. But tell me, in your quantum world, do particles play hide and seek? Or have they moved on to more complex games like Go?
Well, folks, that's a wrap. We've journeyed from ancient atoms to quantum hide and seek with a pit stop at Einstein's family reunion. Remember, whether you're folding space-time or just folding laundry, keep questioning and exploring. Now, if you'll excuse me, I need to go contemplate the quantum state of my leftovers. Stay curious, everyone.
Thank you all. However, I am off to the holodeck for a party, and you are all invited. I would love you all to come if you are up to it.
por tenerte cerca. Oh, 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 na, Redondos míos, baila conmigo en esta noche estrellada, siente el calor, la pasión desatada. cuenta.